This is an opportunity to talk through a variety of issues, variety of questions that have come up in some of the panel discussions that the iStruct team have been having. We'd like to start with a video of open data source and the collaborative data environment from 1994.
One of the biggest construction projects ever undertaken, designed to reach the heavens. But the engineers couldn't finish the job. Halfway through, everybody working on the tower was stricken with the inability to understand what the other fellow was saying. They were all still talking, but they weren't communicating. That incident is supposed to have taken place in about 5000 BC, and we've been trying to understand one another ever since. But not too long ago, thanks to technology, there came along an amazing invention that actually made this problem worse. What is it? The desktop computer, of course. You see, we haven't improved the processes that connect these tasks together. And that's because the software packages that make this computer do its job are made by hundreds of different companies. And each software program has its own way of defining terms for the computer to understand. So they all talk to the computer, but they don't talk to each other.
If you really think about buildings and the things in buildings, furniture, equipment, and so forth, you're really talking about objects, not lines on paper. Well, for the first time, the power of the computer and now the very imaginative creators of software are allowing us to come back and think about buildings in a fundamentally different way. It's collections of objects.
So,
Desks go. The way to replace the technology works the way it's supposed to. Open systems and partnerships are part of Autodesk's corporate philosophy and have been since the company's beginning. They believe that having more choices is inherently better than having fewer choices.
this is not a new problem, obviously. So this is an opportunity to talk with the four people on the panel and have a discussion about interoperability and how our programs communicate. And I hope it's something that you, as the audience, will contribute to and ask difficult questions of. There is a tendency in these things for everybody to agree very nicely, but I'd like to have some good debate. We're going to start by allowing the panel to introduce themselves. Paul, do you want to kick off?
I can do, yes. Is this thing on?
Yeah.
Yeah, hello. So my name is Paul Jeffries. I am head of computational design at Ramboll. To give you a kind of brief CV of my journey through interoperability, before I was at Ramboll, I worked at Arup, where I helped develop their Design Link interoperability platform and a piece of software called Salamander to help link Rhino and Grasshopper, which Arthur and Stephen talked a lot about earlier, through to analysis packages like GSA. After I left Arup, I then rewrote that software is now as an open source and freeware version that everyone can use, and built on top of a library of core components which are reusable and include a bunch of interoperability stuff, which is called Nucleus. As well as that, more recently, I've also now co-founded a startup inside Ramboll called SiteSolve, where we are looking to essentially spin out a generative design platform as commercial software. So I'm now starting to see interoperability from the side of the software vendors as well, in that we need to start looking at how we get that working with other people's workflows.
Great, thank you, Paul. Rob?
Hi, Rob May, work for BuroHappold, and sort of on the right-hand side, a couple of examples of kind of the types of projects I've been involved with, more recently quite big projects, Stadia projects, and kind of complex geometry, hotel building, and then the Beijing new airport that's opening quite soon. It's quite exciting. I'm based in the Bath office, but I've worked kind of in various places in the world. And we decided to try and, as like all of us, kind of sit down and solve this problem of getting information from one place to another. And we tried to kind of go a level above and abstract the issue of getting information from one place to another and built a framework called the Building and Habitats Object Model. At its core, it's an object model a bit like the library that Paul has created, but then there's a framework that allows then to pass those objects over the internet or on your computer from one place to another, and then a common set of interfaces for Grasshopper, Dynamo, and Excel. So the lower right-hand side there is showing just the kind of pull and push components in those three different packages. And what it's enabled us to do, long kind of lists are the lists of open source some of our closed source repositories. There are 66 at the moment repositories that we've got working live on, contributed to by 43 internal and external engineers and software engineers. And so we've really kind of tried to open up that collaborative experience to be able to create lots of adapters. What it enables is you can create a new adapter to a new piece of software now in a few minutes with a template. And then all you need to do is inject your kind of software-specific knowledge to that bit of software to then link through to any other package, writing zero code in Grasshopper, Dynamo, and Excel.
Thank you, Rob. Carla?
Okay, so I guess many of you already know who I am. I have been representing CSI software in the UK now for almost 6 years, but I'm actually doing this for 13 or 14 years now. So I started in Portugal I actually started as a software developer when I was finishing my graduation. I was working in a software for connection design. At that point, we were lacking that feature on our software, so that's how I started. But then I moved on to do quite a lot of training stuff on the software, technical support, well, everything related to CSI software, really. The idea today is obviously also to give you an idea of what are our views in terms of software development, in terms of structural analysis, in the way forward, taking into account this interoperability and BIM environment. And I would say, well, since I started working, the buzz around these two words was pretty on everybody's mind, interoperability and BIM. I remember that in the early days we were focusing on making sure that our software was IFC compatible. But as the years were going by, more and more we felt that the industry was moving towards Revit as our, let's say, accepted BIM platform, particularly for the building industry. So these days we do make a huge effort to make sure that our software is fully compatible with Revit. That being said, in these last few years, we have also invested quite a lot on offering an open application programming interface. And the reason for that, well, there are several reasons. One of not being the least of them, the fact that we have like a 40 years old engine on the making, and we do not want to break or mess with the analysis engine. So all the new stuff, all the new capability that we are developing into our software is actually done through our API. So that's probably primarily the reason why we've developed it. But it's also a tool to offer to all our clients. I know that many of you are actually using our API to do all your post and pre-processing of data of your models. And besides, we are also looking forward to, well, getting into linking our software with companies that have synergies or have any other capabilities that can add value to our software. So that's, let's say, the way I see we moving forward.
Thank you. Madi?
Hey, I'm Madi, and I've been an engineer in AECOM structures team for the last 4 or 5 years. I'm the day-to-day user of model data that kind of finds herself switching between analysis models like SIA and SAP through to visual scripting as Grasshopper and Rhino. And that's because different programs are good for different tasks. And interoperability is essential to being able to switch between those programs and use the best tools for the job. That is the main discussion point for our panel, but one way that we've trialed solving that in our team is by developing and building a translator so that we can modify models across different platforms from a single data point. Interoperability in day-to-day tasks is always something that we come across. So one, in processing large volumes of data, like what you get from wind testing of large airports, for example, that's something that you can easily do in Grasshopper and Rhino, but maybe not so easily straight away in your analysis program. And also rapid prototyping of complex geometries, again, parametrically modeling not only the geometry but also the structural parameters, and being able to flip between the Grasshopper and Rhino and your analysis program is key. And also being able to use bespoke APIs that SAP and SIA allow us to, in order to write our own design checks when they're not already available in the analysis software we use. So I guess I'm here to offer the view of the day-to-day user for who interoperability is absolutely essential in carrying out the design tasks.
Thanks, Madi. That's a great introduction from the panel. I just want to start by having a quick show of hands in the room. How many of you find interoperability between software packages an issue in what you do day to day? That's pretty honest, probably 80, 90%. And how many of you are writing or using bespoke pieces of software that try and get around that interoperability issue? So again, about 50% of you have written or are using bespoke elements. And are most of the people using bespoke elements, is that because the elements in the software packages that you have aren't fit for purpose, or you're finding that the links that you need to make, well, let's start with, are the software packages fit for purpose in this interoperability stage? Do you think they are? Well, that's a pretty resounding no. So that's an interesting start to the discussion, and something I think is reflected in the comments the panel were making, and certainly the conversations I've been having with the panel. So what about data then? Is data, the data that you get from a variety of places, fit for purpose? Paul, is this something you want to talk to? How do we make sure that we can reuse data from other sources effectively in the models that we use and have to rely on?
Yeah, so there's lots of cases where we want to reuse data for reasons that are not necessarily the original purpose. So I think the classic one for structural engineers is taking an architectural model in whatever form and then trying to fit a structure around that or inside that. And I think ultimately it really comes down to communication, because you've got to make sure that the data that you're getting is going to be the latest version, but you've also got to coordinate with the team to make sure that the flow of that data and the way that you're using it is appropriate. So I can think of lots of examples where, for example, people might have modeled a structure in Revit and then have tried to take that into an analysis package, but because of the way that has been modeled in Revit, the ends of the beams don't node out correctly, all sorts of things like that. So the person that is doing that original modeling task could set things up in a way that makes it very difficult for the structural engineer wanting to do analysis on that geometry to do their job in the end. So I think it's all really about communication. It's about making sure that people who are providing the data understand the purpose to which you're going to put that data, and that you understand the purpose to which that data was originally created and are able to tie between that as much as possible.
Great. I'd encourage anybody who has questions or thoughts or contributions, just stick your hand up, and I'll call you when you're... There's one at the back there to start us off, so that's great.
Just a basic question. I'm Ibrahim Fahda from SCI, State Construction Institute. I think we talk about data, but could we define what is data? I know it's a philosophical question, but could we define what is data? Because data could mean defined set of numbers and text, could be something we can access, could be something related to time, could something related to age, data age, because data will age at some point. Because what we can access now, maybe in 50 years, 100 years, we cannot access. I know from myself, if I open an AutoCAD file I created 15 years ago, I cannot open it now. Revit file, if you created a Revit file 5 years ago, if you try to open it now, you might fail to open it. So data is something bigger than what I think we discuss. We need to define what is data.
So, opportunity for the panel. What do you consider data to be? Is it a limited set of numerical information, or is it the entire gamut of information that we generate on a project? And how do we ensure its longevity? Does anyone want to jump in on that? Rob's keen.
I think, well, it's almost unlimited in terms of the answer to the question of what data is, especially if you consider things outside of, structural steel or, multidisciplinary. If I could try and answer from a slightly focused kind of point of view, one of the issues that we've had, I think, as an industry, is we've got these two options in Interop. We've either got a kind of top-down file format like IFC or Revit, that we have to play by those rules and interop and interact with those objects and those descriptions of objects, which is the data. Or we have to basically mince that into integers and strings and numbers to then pass that from one place to another. And I think what we need to be doing is exchanging objects, but just not objects that are necessarily in a proprietary file format, hence trying to open source what we've done in the hope of moving the conversation towards an open source definition of everything that we're trying to do. In terms of the versioning, we've been doing some work quite recently in the framework to basically allow us to effectively never have an object that cannot be read. And so, knowing that these things change and grow and they're very organic, the more people you add into the system, it's a bit like entropy, the more chaotic and diverse the whole object model gets, and it needs to. And it needs to grow and develop. And so exactly that, we need a system which we've implemented a version of, which means that there'll never be an object that can't be read. It'll always be backwards and forwards compatible.
Well, that sounds like a good starting point at solving that issue. Carla, I'm interested in your view from a software perspective about the fixed file formats. You've touched on it already versus your API, single source, IFC, Revit database. It must be hard as a software vendor to deal with all of these potential issues. Are you taking a radically different approach from your competitors, or is this the way that you feel like you need to go?
Well, I can only speak from in the name of computers and structures. I'm not sure how the other software houses are addressing this issue, but as I was telling you, our view is that if we offer the API to our clients, then we kind of make their responsibility to produce a set of results that they can manage in terms of post-processing their results. From our end, what we offer is, since SAP and ETABS have been around, we offer a text file as well. We also integrate with Excel pretty well. And these are, let's say, everyday tools of the engineers. We're not going into more advanced type of interoperability in that regard, but particularly in the sense that the case that this colleague from the audience was kind of putting forward, when you have like an AutoCAD model that it's not compatible between versions. What we always have made sure is that if you guys keep, let's say, a text file of your models, you can, across all the different versions of our software, bring in that information in a text file. So, what it means is that you will have a file that kind of lists in a very simple format all the information that you need to build a structural model, materials, loads, sections, combinations, whatnot. So that information, you will have access to that information for many, many years and across the different versions of the software. So that is, let's say, our responsibility in terms of our piece of software. But then when you guys use the API and you produce your specific set of results, then it's kind of your goal to keep track on how to keep that information forward, I would say.
Madi, does that work for you? Is that a helpful way of working as an end user?
Completely. The APIs have been a very useful tool for us because you often find yourself having to do these bespoke checks, or you're particularly interested in something that isn't already available in the analysis software. So the API kind of opens the door for you. And so from a data point of view, the data that, to me, data is more the attributes that are assigned to those members and the attributes that I can tap into, and then in the API write my script to do whatever I need to do in that particular design task. And so in the context of interoperability, being able to access those attributes across platforms is probably the most practical and useful thing to me as an engineer.
Yeah, I agree with that, but I think the slight problem that we have with software companies releasing APIs instead of putting more effort into addressing interoperability concerns more directly is that then we end up with a situation where I end up writing an interoperability system to suit my needs, Rob writes one to suit his needs, other people in the audience I'm sure have written ones to suit their needs. And I think that ends up with, across the industry, a lot of people redoing the same things over and over again. And obviously me and Rob seem to be in alignment on the fact that we should be open sourcing that a lot more. But then we end up with the situation where we started writing our own thing, we've now open sourced them both, but we've now got something that meets our needs. Where's the kind of glue that actually locks that together, and who is motivated to actually try and make sure that this works another way? Because one thing is making it open source, and I think that's great. But then there's also a lot of effort you've got to put in on top of open source to actually make sure that the community forms around that and things start to develop. And I think that's where we're currently a bit lacking in the industry, is actually releasing things, but then making sure that there's that framework for collaboration around them.
I think the open source topic is fascinating. I think we'll come back to that if that's okay, and take a few more points on the sort of earlier part. There was a question at the front here, Ashley, on the right here. Further on down, here we go.
My question was sort of about open source and interoperability. The rest of the digital industry seems to be coalescing around platforms, and in order to use a piece of software, you have to use something which is part of a platform, and they don't speak to each other. Do we have an example from the rest of the computing world where interoperability has worked and become something that is generally sort of accepted and working?
So that's something that exists, interoperability in the other industries?
In other industries, I would say definitely more than in the construction industry. But, well, the video that we were just seeing kind of tells us that, right? This is a discussion that is more 20 and odd years in the making, and we still don't have a response for this. It's kind of still, I would say, a bit of an utopian concept. But that's why we are all here, right? To kind of raise the awareness for this and create the buzz, and hoping that the next generation will make it possible.
I hope this generation, actually. Rob, do you have examples where it does work? Is aerospace working, for example? I don't know.
The internet.
The internet, okay. That's easy.
The internet. I mean, HTML, the protocols that basically drive the internet have been obviously wildly successful because they've allowed everybody to connect together. So I think this is one of the reasons why in this interoperability kind of discussion, I think we're trying to go to the level of abstraction that we need to, that then you stop talking about and arguing about, you know, attribute names and things like that, and actually argue about the more important things. What are the protocols? What is the internet, if you like, equivalent to us connecting everything together, which reduces all of the friction and allows people to write a small amount of code to exchange from one object model to another.
Yeah, I think I've heard IFC described as its intent is to be the kind of HTML of the built industry. But I would say they've had 25 years based on that video, and it's not quite working out that way yet, would be my view. So HTML has something like 500 different tags, something like that, whereas IFC has about 5,000, I think, different types of objects. And I think that's one real problem, is that even when there is that concerted effort to try and standardize things, the way that that tries to standardize is trying to cover a very wide range of different possibilities. It's not necessarily focusing in on what is common. So certainly when I've been trying to develop interoperability software and things like that, what I've been trying to do is to pull out the most generic, the most sort of bottom layer, the most kind of, spread between different things. Elements that I can. So, for example, in IFC, if you want to describe a linear member, be that a column or a beam or a bit of bracing, then there's about 5 different ways you can do that. Whereas what we need to do in order to help with translating between different formats is try and establish one central definition of what a straight bit of structure that has some sort of profile on it actually means. And then we don't necessarily need to be subdefining all of these different types. We can try and commonalize a lot of things.
There's one more question on the back right there. Thank you.
Hi, Andrew Phillips, Imperial College London. So I think the point about platforms was very interesting before. So we've actually been fighting fairly hard to remove ourselves from platforms. And then I think the other point was using the correct tool for the different processes that you're doing. And I was wondering whether you think actually there's something more within education that we should be trying to put people into the mindset that they should have this kind of flexibility and adaptability to develop their own processes. So you were commenting that you have effectively developed bespoke processes because they work for you and your particular scenarios. And yeah, I don't know if the panel have some sort of thoughts on that, whether we should be looking for a gold standard, because that just feels like moving back to a kind of platform, which inevitably there will be tools that are not appropriate for certain processes. Yeah.
Is that something that you want to pick up, Madi?
From an education point of view, I don't think there'll ever be a case where all the tools that you need are already available to you, or even if they are, whether you'll be able to find them in the time space you've got available to you. So to be able to write your own bespoke bit of code, because sometimes it might be quite a small task but mean a lot or make a big difference. From an education point of view, I think that's very valuable. It's a very valuable skill to have. The fact that there isn't a common source or a fixed file format that we can use at the moment, the way we've found around that, to replace the internet for, in our case, we just have the Google Translate. So that's how we can switch in between different platforms for the time being. I don't know if that answers your question.
Education is a huge topic around this, and it's something where Tim Eibel says this is the first generation which is educating upwards within organisations. Young people are coming into industry and telling their seniors what they don't know, and that process is making major structural changes to firms around the industry. Our panel is quite young, our audience is quite young. I wonder whether there's any contributions from some of our older, more senior, more experienced members who, on how over time that has manifested itself, whether there's something we as young, go-getting, thrusting, irritating people don't get from 20, 30 years of experience. Yes, in the middle there.
I'm not sure I want to be described as one of the older people here, but maybe I am. I mean, because certainly I've been talking about BIM and interoperability for 25 years now, which is a little bit scary because the industry is still waking up to the idea. So, sorry, Peter Deming from Oasis Software. I'll also say interoperability. One of the problems with interoperability is that it's not possible to get 100% interoperability. Each program will always have its own attributes which don't exist in other programs, and so there's maybe like 90% that you can transfer, and certainly that's the target that software developers we're sort of aiming for, to make sure all the common data is shareable. But for that extra 10%, that I guess there will always be a need for those extra tools to top things up.
Well, that's an interesting point that was raised by the panel earlier. We talk about data as if there is one source of it. Is that concept of a single source of truth, data, utopian? Is that realistic, or should we be accepting that we are constantly adding and taking away layers from our base data? Is that something anyone on the panel wants to pick up?
Yeah, so I think there is this idea that's been around for a long time that there should be a single source of truth, and I think that idea has certain merits and certain demerits if you take it a bit too literally. I think not everything has to be in one file. I think the key thing about having a single source of truth is that there should be a single source of control for each aspect of a project. That doesn't necessarily have to be in one file or in one bit of software, but the key thing that I think we're all trying to strive for in interoperability is that you don't have to keep redefining things every step. So you might have certain things which are added at certain parts of the process that are controlled by certain parts of the process, and then different people in that process might want to add things at other points. So for example, in our workflows, we use Grasshopper as pretty much the starting point of a lot of our workflows, and then we take information out of that into analysis packages, BIM packages, and so on. But as you do that, there is always a need to add in extra information for those particular packages, and that's always the difficult part. But it also means that you don't necessarily need to be restricted to just the capabilities of one bit of software, because I think often if you do just rely on one bit of software, then you do end up restricting yourself in design terms. So my favourite example of this is a couple of years ago when I was at Arup. I was working on Sagrada Familia, which Francis showed a lovely image of earlier, and that geometry that Gaudi created 120 years ago with a couple of bits of string, trying to get that into Revit was not a pleasant experience for anyone. So I think if we were solely reliant on a single bit of software and we were trying to do everything in that one bit of software, then that would have really limited what we were able to do on that project.
Some contributions from the floor. Francis, yes, raised.
A question for the panel and maybe for the audience. On what percentage of your projects is a contractual deliverable a BIM model versus drawings?
Should we go through the three of you who have projects involved? What about you, Madi?
On the projects I'm working on at the moment, which is 2, that would make it 50%.
Yeah.
I think of the projects I work on, pretty much all of them now have BIM deliverables, or at least we try and deliver in BIM if we can.
Yeah, I don't know a percentage. I'd say similar, the majority of projects, but also have a BIM and drawing deliverable. I don't think there are many that only have BIM.
So I think that plays a larger issue that, we work all over the world. There are a lot of places, a lot of projects we're working on where, at some point in the process, people don't work in 3D, or they certainly don't claim to work in 3D. I think that is a much bigger issue than just interoperability. But maybe the panel could speak to that, perhaps.
And that's certainly an issue. I assume the future is not evenly distributed within your companies as well as across the industry, and that you're the vanguard of this within the larger organisations that you're representing. How do you deal with that difference and that difference in cultures across wide international spreads?
I think matters what projects you're working on as well. So one project that we get involved with is the Serpentine Pavilion, and right at the beginning, there's lots of different concepts, lots of different sketches that change from day to day, and you need the ability to rapidly prototype that and change the geometry, test it quickly in your analysis model. So that's where interoperability is key. In other projects, you pretty much know what the structural system is right from the beginning, and you can make your changes in your structural analysis package. You don't necessarily need to be going back to script it.
Any other thoughts on culture and across the world?
I think for me it comes back to needing different tools, and so that's why we fight to put the pieces of string into Revit and etc. Because Revit, is quite good at putting things onto 2D drawings, but we, again, it's something that we've spent our own energy on. Interop. That David, maybe you remember the XRL project. We had to write Interop to just get to microstation drawings from AutoCAD, right, and get all the layers right and stuff like that. So. It's just another. I think it's just another spoke of the interop problem. Drawings. I feel like.
I would probably add that that's actually one of the things that it's also in the mind of our developers. Currently, there's quite a big push for us to be able not to produce 2D drawings, but to get 3D reinforcement inside Revit. So that's something that we are adding to the software as something of paramount importance. It's being pushed by our users. So I would say both at the time. So still both.
Take a few more questions from the audience. There's one in the middle here. We'll go for the one on the left first, and then we'll take your question next.
So at the moment, it's obviously we're very platform oriented. And it's small teams of developers that have sprung up to create these plugins and tools to speak to these platforms. There's kind of a fear sometimes that these teams of small developers could have the rug pulled out from underneath them, and practitioners on the ground, that could mean downtime. Is that solved by having an open source format? Or I'd just like to know what your thoughts are.
I think you're talking about downtime in particular software, or you think software being removed from availability?
Yeah, for designers, that if versions change, that these interoperability packages are no longer functional, which for designers means downtime and not a loss of data, but data that we can't work with.
Yeah, that sounds like a key topic. Is that something that your open source system, Rob, or copes with, or is it a...
Yeah, so the first thing that we had to do internally and are still doing is saying, could you please stop writing interop code between this, that and the other over here and write it in the central GitHub system? And we've learned a huge amount by almost aping the tech industry, using their industry standard platforms and processes, continuous integration, and kind of having automated code author servers that continuously go in and check what people are writing and tell them whether they're using the wrong format or they've broken somebody else's bit of code is amazingly powerful now. And it's all because it's all GitHub's kind of a social platform as well. People that are writing code can help each other globally to say, oh, when we wrote that, we meant that, etc., etc. The other thing then is the formatting and the protocol. So now we've got examples of a guy started 2 weeks ago. He committed code to the robot toolkit within a week, and he created a new toolkit for RFEM analysis in 2 days. And so once you start standardizing this stuff, it makes it much, much easier for people, A, to create it, and then somebody else to come in and fix it when it doesn't work, because everyone's following a standard procedure.
I think that's a good cue to go back onto the open source versus closed source discussion. I know, Rob, you're talking about the package that you're developing and BuroHappold are working on is an open source element. How are you finding that? Is that the solution to us all writing our own pieces of software, or is it a building block within that potential output?
Well, so the first thing that we're hoping it will do is move the conversation on. it's open sourced, and so hopefully people will look at it and say, oh, that's how they're doing it. Maybe the next version of what we're doing can be more collaborative, etc. But then equally, you know, why not, if it is working, people start congregate around it in the F equals MA. Maybe we can increase the M a little bit so that we can reduce our F a little bit, or A. And so what we're experiencing again, though, is I think it was University of Cardiff are doing some work with us. And again, it took hours for them to basically plug in one of their libraries and wrap it and build it into the system. So it's the only way, I think, by opening up these common procedures and protocols and doing it as a community, it's the only way that we're going to persuade people to stop doing lots of work on their own kind of interop.
And Carla, obviously, from a software vendor's point of view, open source is a slightly difficult topic. What's your view on it? Do you approach the concept of open source from a different way? I'll come back to you in a minute.
Well, what I could say is, to be completely blunt, I don't think that we would work in anything open source to allow us to talk with other direct competitors. But on some views, or for instance, if we are talking about connecting to companies that have synergies or similar, let's say, additional capability to our software, in those situations, I think we would definitely be keen to develop something open source.
So the commercial realities are different as a vendor.
Precisely, and I think the problem would be raised particularly at the level where we're talking about talking between analysis software packages that are similar between themselves. If we're talking, for instance, about integrating our software with something like Rhino, Grasshopper, Dynamo, things like that, that are, let's say, an extent of what we already do, that is good for us. Yeah. But if we were talking about linking to our direct competitors, I think that would be a problem in terms of open source.
I've got a point on that. There's a question right at the back, and then I'll come to you in a minute. He's got his hand up for a while.
Yeah, hello. My name is Herman Ogink. I'm from SIA, from the Nemetschek group, and I want to raise here a topic what Nemetschek has taken in hands, and that is to work on a neutral exchange format for the analytical software. So the topic we are talking about, we hear it internationally that there is a big demand to exchange that software, but we also hear here. And we took the initiative to start with a neutral format, and I will explain that more in work group 3 at 12:10. And the goal is that we have that exchange format, also enhance it to an open API, and also considering to have it as an open source. So we don't want to have it as an Nemetschek solution. We take the initiative to start with it, and we really hope that the industry and also our competitors or colleagues, how we call them, will join us. And we have already about 7 software companies who are joining this initiative. Just want to mention that.
There was a question here at the front. Sorry.
Hi, James Bailey at WSP. 2 parts, really, to my question. The first part is that obviously everyone in this room, as my colleague at the front said, is kind of a vanguard to this sort of initiative. Everybody's quite motivated to do it. That's obviously not replicated everywhere in every business, and there is, the more you listen to people talk about this, it sounds like engineers, obviously like yourselves, a lot of yourselves are acting more like software developers, software engineers, and I don't necessarily think that, say, university degree courses and whatnot for students are providing that sort of skill set. So they come out of university already outdated in a sense. Maybe not for every university, but the second part is, are we going to see perhaps the breakdown of teams, structural engineering teams in businesses change? Is it going to be more about hiring data scientists, hiring machine learning algorithm experts, etc., to find data trends, than actually sitting down doing your span over depth bending moment calcs, you know? It's interesting what that man at the back just said about obviously interoperability and that neutral software, is that perhaps as a group we have a moral obligation across the industry to have, almost like Google and Facebook, work as a combined unit to develop software that has, meets a certain standard globally. Do we have a similar obligation now within sort of engineering to ensure that if you've learned how to program in Python or use Grasshopper, that you don't go to another company and then find you can't operate because they don't use the same system or the same arrangement.
Madi, is that something that as a working in a team that is obviously computationally aware, do you consider yourselves all structural engineers, or do you have a mix of skills between software engineers and structural engineers, and how does it break down in reality?
I'd say 100% of us all consider ourselves structural engineers, and we don't have someone who is purely a developer in our team. And also, I think everyone within the team learned their scripting skills on the job. But that's why we wouldn't call ourselves developers, because our abilities only go as far as being able to write a few components here and there to write specific tasks. Linking that into the open source argument, I think if we were to write a component and then put it on open source, that's a decision that has to be made right at the beginning, because you often write components with particular problems in mind. And so you write it for yourself for that particular task, and it's not necessarily very useful to other people. So if you've made that decision right at the beginning, you can write it in a more general format and someone else can adapt it and change it and understand it better.
Great. We're drawing to a close our time frame at the minute. There's one question briefly at the front here.
So a thought for you as somebody who is being educated upwards by my younger colleagues. One of the challenges that we find ourselves faced with individually, as well as collectively in terms of the sort of senior management level, is checking of calculations and checking of models. When I first started, checking of hand calcs was a very rapid process. You immediately could spot something that wasn't working. Then we moved to checking of Excel spreadsheets, and debugging an Excel spreadsheet was a more complex task, but gradually over time we developed formats. Checking a script and debugging a script is something that I am no longer equipped to be able to do. Well, never was, but just even understanding the language of a script has been quite a challenge, and it is fundamentally changing how our role is how our roles develop in structural engineering and in facade engineering, etc. And I wanted to know, from the point of view of the user interface, you've talked an awful lot about interoperability of software packages. You're specialists of that, but in terms of the end user, how are you addressing those issues within your respective firms?
That's a fascinating topic, obviously.
Yeah, that's a very big issue, is kind of how you bridge the gap between the people who have these software skills and the people who don't. And that's something that applies to interoperability, I think, because you've got to make sure that when you're taking information from one package to another, that the information is coming across. And as Peter mentioned earlier, that's always almost inevitably not going to be the case. So you need to understand the implications of what data is going to be lost in that process. But also more generally, the processes that are being implemented through code need to be checked by people who are kind of competent to do so. So in our team, what we tend to do is, well, either if one of the more junior people is running it, then I can check the code itself and kind of run through that and review that code. But what we also tend to do on other processes is, as well as writing the code, either before or actually more commonly afterwards, because sometimes you need to play around with the code a bit to figure out the process you want to do, is to actually map out the process that's going through that code. And then that allows us to send that sort of flow chart off to the domain experts who can then check that, and then we have typically data that we can check the outputs against to make sure that what is being produced is what it should be being produced.
Is that a similar approach at BuroHappold?
Yeah, in a way, we've also kind of drawn quite a hard line between script and code. So in the script category, we include Excel, Grasshopper, Dynamo, and it's effectively, we've decided, impossible to create a curated, version-controlled set of scripts or Excel spreadsheets in the firm for all disciplines. We've had issues with spreadsheets from kind of reinforced concrete councils and stuff like that. It's very, very difficult to have test and have really robust Excel spreadsheets. So we've drawn this line to say there's scripts over here, and you basically apply exactly the same QMS procedures and logic that you would do with an Excel spreadsheet. But also, we don't really want people to be doing lots of member sizing and doing engineering inside scripts, because they are quite difficult to check. Actually, once you get into member sizing and doing kind of calculations, we either want people to go into commercial packages, which have a bit more robustness, hence us focusing on interoperability, or then we actually switch over to a code, properly curated, managed set of components or methods that then load back into the script. And as I was talking earlier, then the GitHub environment and that kind of very, very tightly controlled machine checks as well as human checks is where we will that's the only place where we will put things, that design elements, for example, that get deployed across the practice. And again, learning from the industry, the technology industry, we have unit tests inside the code. So you'll have a set of standard structural engineering problems that the computer must solve when somebody's written the particular method, and it will run thousands of times to make sure that it is absolutely robust and fit for purpose before it goes outside of or gets deployed. So that's that hard line between kind of script and code.
That's fascinating. It's been a really good discussion. I'm sure we'd all like to thank the panelists for discussing that, and then we can continue that over lunch. Thank you.